For most of human history, people assumed the universe must have a center, a single location where everything began and around which everything else revolved. This assumption feels natural because it reflects how humans experience the world. Cities have centers, maps have middles, and stories usually start from a particular place. For centuries, Earth itself was believed to occupy the center of the cosmos, and when that idea was overturned, the sun replaced Earth as a new central point. Later, even the Milky Way was once thought to sit at the heart of everything. Each time science advanced, the center moved farther away from us, not because humans were becoming less important, but because the universe itself does not organize around human intuition. Modern cosmology now presents an even more unsettling conclusion. The universe may have no center at all. There is no special location, no cosmic middle, and no preferred position from which everything else originates. Wherever an observer is located, the large-scale universe appears essentially the same, and that simple observation forces us to rethink what it means for something to exist without a center. When scientists describe a universe as expanding, it is easy to imagine a massive explosion, with matter flying outward from a central point into empty space. This image is intuitive, but it is fundamentally misleading. The universe did not expand into space. Space itself expanded. Every region of the universe was once much closer together, and as time passed, the distances between regions increased. A helpful way to visualize this is by imagining the surface of a balloon. As the balloon inflates, every point on its surface moves away from every other point. No location on the surface is the center of the expansion. The center exists, but it lies outside the surface itself. In the same way, the expansion of the universe does not have a center within space. From inside the universe, every observer sees other galaxies moving away, and every observer could reasonably conclude that they are at the center, even though no such center exists. This understanding dramatically changes how we interpret the Big Bang. Contrary to popular imagery, the Big Bang was not an explosion that occurred at a single place in space. It was an expansion of space everywhere at once. Every region of the universe was once extremely hot, dense, and energetic. There was no empty space waiting to be filled, and there was no privileged point from which the universe emerged. If the universe has no center today, then it likely never had one. The Big Bang happened here and there and everywhere simultaneously. This idea is difficult to visualize because human experience is rooted in localized events, but the mathematics of cosmology and the evidence collected over decades consistently support this interpretation. One of the strongest pieces of evidence for a centerless universe is the cosmic microwave background radiation. This faint glow fills the entire sky and represents leftover energy from the early universe, released when space cooled enough for atoms to form. When scientists measure this radiation, they find that it is remarkably uniform in every direction. If the universe had a center or a preferred location, this radiation would appear stronger in some directions and weaker in others. Instead, it looks almost the same no matter where we look. This uniformity suggests that the early universe was nearly identical everywhere, reinforcing the idea that no location was special even in the universe's earliest moments. Another key observation comes from the motion of distant galaxies. Astronomers have discovered that galaxies are moving away from each other, and that the farther apart two galaxies are, the faster they appear to recede. This relationship, known as Hubble's law, holds true in every direction. Importantly, this pattern would look the same from any galaxy in the universe. If observers lived in a distant galaxy billions of light years away, they would see the Milky Way moving away from them in exactly the same way we see other galaxies moving away from us. This symmetry forms the basis of the cosmological principle, which states that the universe is homogeneous and isotropic on large scales. In simpler terms, the universe looks the same everywhere and in every direction, and no location is fundamentally different from any other. A universe without a center naturally raises deeper questions about its size and shape. Is the universe infinite, extending endlessly in all directions, or is it finite but unbounded? At present, science does not have a definitive answer. A universe can be finite without having an edge, much like the surface of a sphere is finite, but has no boundary. Traveling far enough in one direction on such a surface eventually brings you back to your starting point, without ever encountering an edge. The universe could have a similar structure, or it could be truly infinite. What we do know is that the observable universe represents only a portion of the whole. Light has had a finite amount of time to travel since the Big Bang, and beyond a certain distance, information simply has not had enough time to reach us. Beyond this cosmic horizon, the universe may continue in ways we cannot directly observe. The absence of center can feel unsettling, because humans instinctively seek reference points. We want to know where we stand and how everything relates to us. Throughout history, scientific discoveries have repeatedly challenged this desire. Earth lost its central position, then the sun, then the galaxy, and now even the universe itself appears to lack a center. Each step has required humanity to let go of a comforting assumption, yet none of these discoveries diminish the richness or meaning of existence. Instead, they expanded our understanding of the universe and our place within it. In a universe without a center, meaning does not arise from location. No place is inherently more important than any other. Earth is not cosmically privileged, but it is not insignificant either. The same physical laws that govern the behavior of distant galaxies also govern the atoms in our bodies. The same expansion that stretches space across billions of light years defines the structure of the universe as a whole. From this perspective, every location is equally ordinary and equally extraordinary. The absence of a center removes hierarchy from space itself, replacing it with a vast and consistent order governed by universal laws. This realization also reshapes how we think about observation. In a centerless universe, every observer sees a universe unfolding in the same way. There is no single vantage point that reveals a more complete or more authentic view of reality. Knowledge is not tied to position, but to measurement, reasoning, and interpretation. The universe can be understood from anywhere, provided the tools and methods are available. This universality of understanding is one of the most profound aspects of modern science. Despite its immense scale and lack of a central anchor, the universe is not chaotic or unknowable. It follows patterns that can be measured, modeled, and predicted. Through careful observation and theoretical insight, humans have uncovered the structure of a cosmos that does not revolve around them. In doing so, the universe becomes aware of itself, not through a central point in space, but through countless observers spread across its vast expanse. Consciousness does not require a cosmic center to exist. It emerges wherever conditions allow complexity to arise. Ultimately, the idea that the universe has no center invites a quieter, more expansive perspective. It encourages humility without despair and curiosity without fear. The universe does not place us at the center, but it does allow us to observe, to question, and to understand. From any point in space, the same cosmic story unfolds, governed by the same laws and shaped by the same history. In a universe without a center, every place is part of the whole, and every observer participates in the ongoing act of discovery